What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. I got a rock. 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 I got a rock. I got a rock. I got a rock. Rock.
What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. A rock. I got a rock. I got a rock. Got a rock.
What did you What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock. Got a rock. 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 I got a rock. I got a rock. 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 I got a rock. I got a rock.
All right, so excuse me. Today we're going to start on with the next topic, which is encapsulation. Now, when I say encapsulation, we'll define what that is precisely here in a moment, but for practical purposes, in C, that means defining what are called structures, and in Java, that means defining classes. You've already defined classes, but now we'll actually get into the object-oriented version of what we mean by that. Remember that we are on Piazza and we are on YouTube, so if you have any questions, go ahead and post there. Otherwise, just using single pieces of data is very limiting. If you only have, not everything is just one integer. Not everything is just one double or one character. And not even a sequence of characters, a string or something like that. Real world entities are composed of multiple pieces of data. When we program something to model that real world entity, I would like to take each one of those pieces of data that makes up that one thing, and I would like to group them together, right? That's what encapsulation is. Encapsulating multiple pieces of data into one object or thing in general allows you to deal with that one thing, right? Rather than just a bunch of different pieces of data. Think about a typical student. A student has a first name and a last name. They have an NUID, they have a GPA, right? If I kept all 4 of these pieces of data in separate, variables, then I've got 4 variables to represent this one student. Not only that, but if you start having a roster of students and you have multiple students, now I've got an array of first names, an array of last names, an array of GPAs. If you want to sort them, or if you want to do anything with them, any sort of data manipulation with them, that means that you're doing all this juggling of all these different arrays. Whereas if you had taken all those 4 pieces of data and put them into one thing, now you can actually have an array of this first thing, this first student, the second student, the third student, etc. And both languages support that through different means. Right? Again, the solution is encapsulation. You'll see this tomorrow in your lab, by the way, where we give you a bunch of baseball teams and we don't use structures. We don't use a class. Instead, we use a bunch of different pieces of data, and you'll see behind the scenes what a pain it is to sort those things and to process that data. Anyway, the solution in C is going to be structures, and in Java, we define classes. So more formally, what is encapsulation? Encapsulation is actually a mechanism that allows you to do 3 things. Right? One, you can group pieces of data together to form one logical unit. Right? 2, you can protect that data from the outside world / code. When I say outside world, I mean code outside of that class or outside of that structure, but not the real world, right? Basically code that is outside of that unit that you've just defined. And then you can also group functionality that acts on that data with the data. Right? So in C, structures support just number 1. Right? They don't support the second 2. The protection of data or the grouping of functionality that acts on that data. There are conventions that allow you to do that using function pointers for the third one and using special naming conventions for the second one. But those are hackish workarounds for what I would term weak encapsulation. So this is weak encapsulation. But as we'll see in Java, Java supports all 3. And you have strong encapsulation. There we go. Okay. So let's go ahead and just start out, and I'm going to do this tutorial style. Let's go ahead and start out in C. Example in C. I change it from year to year. We can choose what we want to do. We can design a student object. I think that's what's in the book, though. We can design a structure to be an album. I think that's in your labs, though. Maybe, I'm not sure. We could design a structure to represent a film. We could represent a bank account. We could do a lot of different things. So, player's choice. What do we want to model? Student? Okay. You don't want to get too fancy? All right. All right, so let's go ahead and model a student. Write a structure to model a student. Okay, here is the basic syntax. Now I'm over here in my IDE here, right? So to define a structure, you use typedef. Actually, where have we seen that before? With enumerated types in our header files, right? There we did typedef enum because we were defining a type of which is an enumeration. Here we're defining a different type. We're defining a structure. Right? And to save on letters, we're going to just call it struct instead. Otherwise, we have the same opening and curly brackets. Now, I'm also going to name this structure. So if we're going to go ahead and represent a student, what should I call this? Student. Should I call it students? No, it's one thing, right? Now, if I've got an array of a student 1, student 2, student 3, The array could be called students, but this is just one thing. Don't pluralize it, okay? And then finally, you put a semicolon right there, okay? There are some alternatives to declaring structures. Read the book for more, but this is how we're going to do it for this demonstration. Now, I've got opening and closing curly brackets. This is what's going to allow me to encapsulate, group those pieces of data together into one logical unit. All I need to do is define what a student is, what pieces of data belong to a student. So tell me, how would you model a student? Name? Okay. So just name. Age? Okay. A year, what do you mean year? Okay, a matriculation year. What do we call that? Oh, just year for now. Okay. Unknown. All right, well, let's focus on name first of all. What type is name? It's a string, and in C, we use a char star to indicate that. Now let's think ahead here with our design though. A name, what is my name? Hopefully you know my name. Okay, so I heard two words there, right? A first name and a last name. So if I were to just do it with one name, right, would I do it last name, comma, space, first name? Or would I do it first name, space, last name? Or first name, I'll do a CSV version. First name, comma, last name. Right? All three of those are kind of ambiguous. What's a better solution? Let's go ahead and split it up into two fields. First name and last name. And if you want to get really fancy, you could go ahead and have a middle initial, or last name, or middle name. You could have suffix, you could have prefix, you could have blah, 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 right? Just think about what we're doing is we're taking this real world object, a person, a student, and we're decomposing them into their constituent parts. You can get as complicated as you want, but I'm just going to keep it simple for now. First name, last name, that's good enough. Note the syntax here. Of course, that's the type. That's the variable name. And then what's at the end here? A semicolon. This is different from a type def enum that was a list and the comma and you used commas. Here, this is kind of a list, but it's this string and that string and that string and that string. These are full variables, and since they're full variables, you need semicolons at the end. Right? There is this string variable called first name, period, right? Just like in a sentence in an essay or something. All right, well, what about, let's go ahead and keep year. I like that for now. Well, actually, spoiler alert. How do I represent year? So freshman, sophomore, senior, junior, senior. Or graduate, or pre-freshman, or visiting student, or ... We'll keep it simple. You could have, well, you'd only be one at a time, right? Like, if I were doing this in a real system, what I would do is I would keep track of your credit hours because that's what defines you, right? Many of you might have come in with so many credit hours from AP or something like that that you already had sophomore status or something. Or certainly after maybe your first semester, you might have enough credit hours to qualify as a sophomore. And that's, so your status, your year is actually a function of the number of credit hours completed. So I would actually keep track of the number of credit hours completed, write a function to determine what you are, right? But let's go ahead and keep it simple. I'll just go ahead and keep it as year, but should we do it as a string or should we do it as, what's an alternative? An int, according to my spoiler, right? So an int, what do you mean by a year? A freshman would be what value? One, okay. A sophomore then would be what? Two, okay. This is sounding kind of like a list, right? Freshman, sophomore, junior, senior, other. Right? If we've got a list of values, what should we be doing? Let's make an enumerated type. I like that. Type def enum. And we'll call it year, right? Or whatever. And let's do a list here. You said that freshman should be 1. Are you rethinking that now? 0? Okay. That's what will be the default when I write this. Freshman, sophomore, junior, and senior. There we go. Does anybody else mispronounce things to remember how to spell them in their head? All right, that's the only way I can do it. All right, so instead of an int, it's going to be a year. Year. So now you see why I used an upper camel casing here and an upper camel casing here. When I define my own types, I need a different name than I'm using for variable names. Otherwise, what would it look like? Year, right? That's kind of confusing. So actual types will follow an upper camel casing convention, right? And we're adopting that for C because that's what's used in Java. Okay, I like that so far. What about, I'm going to go ahead and add one more thing just for variety, double GPA. Right? And then the last thing that you said was what? Their age? Or I think, right? Age? Okay. So you're 19, right? What happens on your birthday? You turn 20, right? And so you have to detect, well, what's your birthday? Right? So which one of those pieces of data? Just the age or the actual birthday? Combined with, of course, some time library that tells you what day it is. Which one gives you more information? Birthday. Or date of birth. I like that. Date of birth. Okay. So, but that leads to a question of how do we represent a date of birth? How is time represented? Like, what is today? Tuesday, October 26th, 2021, right? So I'm hearing a day, just the date, right? We don't need to keep track of the day of the week, but a month, a day of the month, and a year. Right?
Some other structure.
Three things. If you've got more than one thing making up a logical unit, then you've got another structure to define. So let's do that. Type def, struct.
Does it matter where you define it? So if you're using the structure in your second, you have to define it before.
Yep, you've already jumped ahead here. I'm intentionally doing it down here to show you that it won't work. So yes, let's go ahead and go with date, right? And what did you say? That it's a month, a day, and a year? I won't go date because it's the day of the month, if you want to do it that way. Otherwise, I'll just go day and year. Right? Actually, you should go proper order here. Year, month, day. You should write all of your dates like that. Why? Because it's lexicographically correct. Right? Europeans, Americans, they do it differently with, month, day, year, or day, month, year. They're both wrong. The correct way is to do it lexicographically. The year, then the month, then the day, right? The most general down to the most specific so that you have a nice lexicographic ordering, right? All right, what types should those be? Strings? 2021, does that sound like a string to you? No, okay. Int, all right, I like that. But some alternatives. Let's think about some alternatives. Does anybody know how Unix or how most computers represent time? Just one number. Right? It's called the Unix Epoch. Let's go here. Right? Unix time epoch. There we go. Okay, epoch converter. So what time is it? It's 1635264970 right now. It's the number of milliseconds since January 1st, 1970. That's known as the Unix Epoch. From there, it just started clicking forward one number, right? The number of milliseconds since that time. You can go back in time, the number of milliseconds, negative, right? Before that. That becomes the Unix Epoch, and that's how most computers store their data. Yeah?
Was this the whole
It's related, but it's yet to come. Unix Epoch problem. I don't know, Wikipedia maybe will tell us. Yep, the year 2038 problem. So this will happen in your lifetimes. We'll have yet another Y2K issue. It's for Unix systems that have only allocated a signed 32-bit number to represent the number of milliseconds. From 1970 to the year 2038, and then some change, that's when you reach the maximum value that you can store in an integer, and it rolls back over to 68 years before 1970, like 1902 or something like that. And so yes, we will have that problem eventually. If you're on a 64-bit system, you're good for several trillion years though. So most systems are like that. It's the same problem though, of course, because you've got a finite representation of time, which can be infinite. And so the Y2K problem was only storing 2 digits for the year, meaning that when you got to the year 2000, it rolled back over to 1900. This is a similar problem because we're only using 32-bit integers. But again, most computers are going to be 64-bit, and they're going to use a 64-bit number, giving you what, year some trillion. I don't know. You'd have to do the math, right? But otherwise, the epoch counter here just goes up every millisecond or so. Or this looks like it's being converted to seconds, but there's an actual number, right? And it's one number. So alternatively, what we could have done is simply just had one number and then worry about all the conversions to date, month, year, etc., using a library. In fact, you would use a library, right? And another alternative would be there's a standard. There's an IEEE standard, ISO standard, 1306. Is it? ISO time standard. 8601, there it is. Right? 8601 is a time standard that uses a string representation here instead. And you can see over here that it is proper, a year, month, day, and then this T separator optionally, and then followed by a 24-hour time all the way down to the Greenwich Mean Time offset. So that is another way of representing time as a single string. There are pros and cons to each one of these representations. Even this one that we came up with is not the best. In fact, what is the solution? What is the best solution? I don't know how to represent time. This seems like a problem that a lot of people have probably encountered before. Use a library, right? Exactly. And in C, there is a library. You've probably seen it before. If not, go back to a couple of labs. I think in the first lab we even do it when you calculate birthdays, or maybe that's the second lab. There is a time T, or maybe it's a date T. Right? That underscore, what do you think that underscore stands for? Type, right? But we'll go ahead and create our own date here, right? And we'll use it. And as you might expect, as you raised earlier, if I try to compile this, of course it's not going to know what the hell is a date, right? Why? Because variables have to be declared before you can use them. If I'm going to use it on line 17, where does this declaration need to be? Up above. Right? I think that that's also true of enumerated types. If I try to use this enumerated type and push it down here, it's going to complain about the same thing. Right? It doesn't know what year is. So I'll put it back up there. Order matters. Okay? Great. So I'm going to go ahead and put this into the notes, and let's make some observations. There we go. Observations. Right. You use typedef struct to declare a structure. Right. Use opening, closing curly brackets to encapsulate multiple variables. Right. You generally use a upper camel casing convention for enumerated types, or for the structure's name, and lower, in fact, hopefully you noticed what I was using, lower camel casing for its member variables. Right? That's what we call those things. That a student is a first name, a last name, a year, a GPA, and a date of birth. Those are its members, right? Those are the variables that belong to that structure. Those are just conventions. In fact, they're not. There are alternative conventions used in C, especially old school C. Yeah.
So why is year an enumerated type and not a structure? If we wanted to make it a structure, can we do that?
You could, but then what would the variable be? It would be an integer, right? And then now you're back to square one of, okay, well, 0 represents freshman, 1 represents sophomore, 2 represents junior, right? So you would just have you would introduce another level of complexity without adding any abstraction to it. Right. All right. So you use semicolons at the end of each variable and the structure's name. Other matters, order matters. If you use a structure inside another structure, it must be declared first. Right. And since you did ask for us to do, for the student demonstration here, this is the diagram from the book. Here we used an NUID, so I like that. Let's go ahead and go back here and add an NUID. Int NUID. By the way, the order generally doesn't matter unless you have things like a static character array, and that always needs to be at the end. But we're not going to do any of that, so don't worry about the order. Put the order that makes sense. All right. There are some tricks and tips that you can use to optimize order in a structure. Don't worry about that. Those are low-level details. Okay. But otherwise, if this structure, it contains several variables, right? It's a box that contains all these variables and their values. And within that box, say date of birth, we've got another box, right? And inside that box, that's got other variables. You could have a structure containing a structure containing a structure containing a structure if you really wanted to. That kind of depth is probably getting to be too much, though. You might want to rethink how you're doing it. All right? All right. So, order matters. It must be declared first. Usually, these structures are put into a header file. Usually, structures are placed into a header file. In this case, since we're doing a student structure, I should name my header file student.h, right? And then I'll go ahead and use that. When a structure contains another structure, we say it is composed of that structure and other variables. And this goes back to, again, way up here when I was talking about composition. This is actually known as composition, that this thing is composed of other pieces of data, and that's composition. Okay? That's what I mean by composition. It's composed of other things. It's not like you're composing an opera or something like that. So let's go ahead and fix this. And I'm going to take all three of these things and put them into a student.h file. There we go. And remove them, and now simply include student.h. And now you've got all those declarations. Much cleaner code, right? And student stuff belongs in the student source file. Demo stuff belongs over here, right? Separation of concerns. Yeah.
What does that touch?
Oh, touch is just creating a file without any content. So touch foo.txt, and you see that foo.txt now appears over here, but there's nothing in it. That saves me from having to go right-click, new, file, name it, right? It's just a quick, touching a file that already exists also updates its last timestamp. So if you want to force, like if something is, here's a sysadmin trick that if there's a process that is monitoring a file for changes, and you don't want to make any changes, but you want to force it to make to realize those changes, or you know, kick it, fawns it was what I call it. Does anybody know who the fawns is? From Happy Days, yeah, right. What he magically fixed the jukebox all the time. How? He just went up to it and hit it or kicked it, right? And so you fawns it, you kick it, and it starts working, right? And touching it will update its last modified date, and you know, get things going sometimes. Right?
So like when we were working with the image utils, like you have to like reopen it.
Yeah, sometimes it wouldn't refresh, so close it, open it up again. Sometimes, yeah. Again, fawns it.
Is there also like a make directory command?
Yeah, there's mkdir, make directory, right? Touch file. Right? You can't touch a directory though. If I touch foo, then that will just make a file called foo with no extension. All right? Okay. So little tricks as we go along there. What about doing the same exact thing in Java? We're going to design a class that models a student. All right, ignore me for a second. There. You would ask for me to do the one thing that was already in this project. That was for not even for a computer science 1 course. That was for like a CS3 that I was demonstrating something. But anyway, let's go ahead and do the same thing over here. I'm going to go ahead and steal this over here so I don't have to retype everything. And NUID is an integer. What I'm going to do, let me go ahead and, yeah, okay, that's its formatting. But I don't have char stars in Java, do I? What do I have? A string, right? You have lists for integers, but a list of characters is going to be a string. String, string, there we go. Year, we'll come back to that here in a second. Otherwise, double is the same. And then date. Now, again, if you've got, the very first question you should ask yourself when problem solving is, does a solution already exist? Over in C it does, it's just kind of hard to work with, but over here in Java, it's perfectly valid to work with it. It's called a local date. Right? Local date, I'm going to go ahead and bring it in so I don't have to create another class. But you could have, you could create your own date time class or date class and then compose it of those 3 elements. But it's already done for me. And all that math of figuring out of, 50 days from now, what's the date? It can handle that. Is this a leap year? Right? In which case you need to add another date, right? And all that kind of stuff is taken care of by the library. Right? And I don't have to worry about it. Yeah? It depends. I'll show you how to use it here in a second, but local date dot, well, all right. I'm not going to be able to do that until we fix the other things. All right? What about year here? Okay, new class, in particular an enumerated type if we wanted to do this. So year, right? And here I will steal the code from before. There we go. Format that. Eclipse wants to format enumerated types all in one line. Fine, go ahead. I'll let it have its fun. But otherwise, if I were typing this out, I would prefer that kind of syntax. Right? I mean, it is a list after all, right? Okay. And now it's happy about that. Right? Let's format everything up. Great. Now let's go back to the original definition of encapsulation. Encapsulation is the grouping of pieces of data that work as one logical unit. We accomplished that in C. I want to now, and now we've accomplished that in Java. What I want to do now is I want to protect that data from the outside world, and I also want to group functionality that acts on that data. Right? We'll save that maybe for a little bit later here, but otherwise, I want to protect that data right now. And what I mean by that is let's go ahead and go over to this demo class over here, and let's create a new student. Me. Right? Just like you create a new list, you create a new student, and this is called a constructor. We'll get into that here in a little bit. But otherwise, that allows me to create a new student. Me dot first name is equal to Chris. Me dot last name is equal to that. Me dot GPA. What should I have? 3.5. All right. Me dot. Always do better than that. But my NUID is going to be 35140602. Right? And me dot. What else? My year. Right. What do you want to make me? I'll join you freshmen, right? Most of you are freshmen, right? Great. Me dot 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 dot. Right? This is the accessor function. The component selection operator is what it's called in C. It's exactly the same thing in C, but the technical name is the direct component selection operator. That's a little bit of a mouthful. What else should we call it? What is it? It's a dot. So call it the dot operator, right? Just call it dot. That's what it is. But you'll see here that I'm outside of the student class, right? If I go back to the student class, the student has an NUID, a first name and a last name, etc. But I'm outside that class right now. I can go into the class and manipulate the data directly by going me dot whatever and then setting it, or I could get it by and print it out if I really wanted to. I could do a lot of things, right? Let me go ahead and create another student here just so that we understand. Jane. Right? Jane Doe. She's doing much better than I am, 4.0. And her NUID is 1234, and she's already a sophomore. Right? Different values. Right? Not on me, but on Jane. Ooh, magic. Black magic. What did I just do? Yeah, go ahead.
So, just to be clear, in C, instead of using a structure, we created a class.
Mm-hmm.
For
We created a enumerated type class, yes. And so it's not public class, it is public enum. It's still technically a class, but don't let that secret out, right? There are built-in methods that you can call on that, like a two-string method and stuff like that. It is a class.
Does it have to be in a separate file?
No, but then you get into issues of, let me go ahead and put it over here in the student file. Where would I put it? It'll never find it. I have to put it, everything in Java is a class or belongs to a class. I can put it as an inner class, right? And it's not a subclass, it's an inner class. A subclass would involve inheritance, which we're not even going to get to in this class. This is just an inner class. Now, in order to get freshmen, I would have to go student dot, and I would actually need a student dot year dot freshman. I've added a layer of complexity, and it's not really buying me anything, right? I could simplify it a little bit by going static, public static, or does static come first? There we go. And now I don't have to have an instance of the class. I don't have to go me dot year dot freshman. Now I can go student dot year dot freshman. But again, it's an added layer of complexity that doesn't really buy you anything. Right? So we'll go ahead and keep it like this. Right? Let's see, where was I? Oh, okay. So yeah, over here in demo, I can go ahead and change everything. By the way, that black magic, what was it? I think it's, well, on a Mac, it's going to be Option Command A. On Windows, it would probably be like Control Shift A or something like that. This is block selection mode, and you can select blocks, delete blocks, and type into blocks. Right? I'll undo all that because I screwed up student there. Go out of block selection mode and you're back into line selection mode. Right? So very cool, and I'll show you another usage here in a second. Yeah.
What's going to happen to like Jane if we don't assign anything for you?
Then, good question. It'll be null. Right? It'd be like assigning it to null. The default values of objects are going to be null. The default values of numbers, like say GPA or NUID, are going to be 0. First name, last name would end up being null as well. Okay. All right, so the point is that I have not protected any of this stuff. What's to stop me from entering a GPA of negative 3.5? Nothing. What's to stop me from not having a year value here for Jane? What's to stop me from not having a proper name for me, right? Or an invalid NUID, negative value, or one that's not even eight numbers, one that's 9 and it's negative, right? I'm not protecting this data at all. You can do whatever you want with this data because it's open to the world. Now I'm going to go back and do number 2 of encapsulation and protect that data by making it private. Private. I just made them all private. Right? Now let's go back over here to demo. All of that is now a compiler error. You are not allowed access to that private data inside that class. Okay? Which is a good thing, because I shouldn't be able to just arbitrarily set it to whatever I want, whenever I want, wherever I want. I want to control side effects. Just like you want to limit the scope of variables and use for int I equals blah, 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 instead of having one global variable I for every single loop that you would ever need, right? You want to limit the scope of variables. You want to limit the scope of who can access and change these variables, okay? So now all of this is going to be a compiler error. We'll come back to it though. Alternatively, there are other names, for example, public. That restores it right back. Right? Now everybody can see it. You'll note that in the original I had no keyword here at all. That makes it what's called package protected. Any other class in the package can see it. That's why I saw it before without a keyword. You can make it protected. We're not going to do that because that involves inheritance, like you asked before, of actually subclassing. Here's a student, here's a graduate student, here's an undergraduate student. Both of them are students, but they're different types of students with different pieces of data, different behavior, right? It's more specific behavior down here, more general and generic behavior up here. We're not going to get into inheritance here. Right? So that leaves private. You should limit the scope as much as possible until you have a reason to not do so, to open it up a little bit more. But there are ways that you can open it up that are proper than just making them public, okay? For example, you could create, well, let's go back over to the demo and let's look at the problem now. One of the problems is me. How do I ever set my first name? I've closed it off to the outside world. I've bricked it up. I can't get in there and change my name to Chris anymore. Create a method to do it. And those methods are called constructors. Right? So public student. And what I'm going to do is I'm going to take that first name, string first name, and I will set first name equal to first name. Right? Well, I'm also going to want to do the last name, the year, the NUID, et cetera, et cetera, et cetera. So I've got a lot of typing ahead of me. String last name, and then last name equals last name. Bear with me while I type, or there must be a better way. Autocomplete, but it won't be auto. It's almost auto. You still need to click, and click, and you're done. Right? So let's go back, delete all this. There we go. So click source, generate constructor using fields. Now you can have multiple constructors if you want. You can have a constructor that just takes the NUID, in which case you can go ahead and zero all these out. You can have a constructor that takes the NUID and the first name and the last name, but not the other three, and then set default values for those. You could have the default constructor that was already provided, let me cancel out of this, was the no argument constructor. Right? It just sets all the default values to null, 0, false, right? But now what I actually want to do is I want to take those, and I don't want to have to do all my typing. So source, generate constructor using fields, hit generate, and you're done. Awesome. Now, one thing that, by showing you that, one thing that I'm not able to demonstrate here is the this keyword. Ignore the super as well. All right? So, student takes an NUID, first name, last name, blah, 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 blah. Let's come back over here to demo and see that it now no longer compiles. Why? Because I just defined my own constructor, right? So that default constructor, that default no argument constructor has gone away. It's kind of like a lawyer. If you cannot afford one, one will be provided for you, right? The default constructor, if you can't afford a constructor, a default constructor will be provided for you, but it doesn't do anything, right? Just like the free lawyer probably. But that's why you got to get. That's why you always got to get a good lawyer, right? Especially if you're guilty. Right? If you're innocent, maybe a bad lawyer will suffice. But anyway, now I actually have to provide all those things. I have to provide my NUID 3510602, Chris, Kurt. I gave myself a 3.5 and my year dot freshman. There we go. Is that everything? Or what else did I need? Year. Oh, year comes first, and then my date of birth is last. Okay. What was the order again? I forget. Let's get rid of that. First name, then last name, then year, then GPA, right? And in fact, this can get quite long. If you've got like 10 things and you're always forgetting the order too, there are better patterns to follow, but that goes way beyond this, the scope of this course. There are design patterns. You can have creational patterns. You can have a fluent pattern to have a creational pattern, a factory pattern, et cetera. The ways that to help you remember how to do these things and do them a little bit better. But for now, this is good enough. Right? I made it too big. Let me go ahead and get rid of that. There we go. So that last one I set to null. Right? Why? How do I create a local date? Well, let's come over here and demonstrate now how to use that. So local date, today. Today is of, that's what it is. Local date.of. They don't have constructors. They designed this intentionally to, actually they do have constructors, but they're all private constructors. And remember, private closes it off to the outside world. So they did a different design approach. They are forcing you to use all these static builder methods. Local date of, and then you provide it the year, the month, and the day of the month. So the year here is 2021. Today is 2021. It is the 10th and, month, and it is the 26th day. There we go. And of course, I'm going to have to import this now. There we go. And I could go ahead and say that I was born today. Right? Because I ain't giving you my real birthday. Right? All right. We can do the same thing for Jane here, but I'll show you a different way of doing everything in line here. 1, 2, 3, 4. Jane Doe. She was what, a sophomore? And doing much better than I am. And today, instead of saying today, I'll go ahead and create another local date dot of, and then provide a year. I don't know. 1990, and then today's her birthday, let's say. 10/26. There we go. Yeah. No question? No? Okay. All right. That gets rid of the need of doing all of that everywhere. In fact, that also solves another problem here. Anytime I want to create something, I would have to, without this constructor, I would have to create it, and then I would have to set each one of these values. Whereas, of course, I can just call this method, hand off all those values, and have the constructor take care of it for me. Right? And I've created two people here now. There is a lot of yellow warnings here. Warning, 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 warning. Right? What's going on here? Let's go ahead and focus on this first line. NUID is equal to NUID. First of all, that line by itself is kind of suspect, right? If I have int x equals to 42, and I go x is equal to x, does that line 16, does that make any sense? I mean, it kind of makes sense. Take whatever's in x to begin with and put it right back in. Yeah, it's redundant. It's useless, right? And that's what the warning will tell you. The assignment to a variable x has no effect. If it has no effect, why did you write that piece of code? Each one of these has no effect because there are actually two variables called NUID within the scope right now. There is the private integer variable that is part of the class, and then there is the integer variable that is part of the parameters. So I've got two variables named NUID here. I need a precedence. This one is going to be the parameter variable. So all this is doing is setting the parameter variable to itself. What I need to do is I need to take this parameter variable, NUID, and I need to put it into this variable up here. Did you hear the key word that I used? Take this, or sorry, I shouldn't use it twice. Take this NUID and put it into this NUID. And that's what was there before, this dot. Right? So that's how I disambiguate which NUID are you talking about. This student's NUID, set it equal to the NUID that I was given as my parameter. Likewise, you need to do the same thing for all of the others. This dot. Right? And there's that dot operator again. This dot last name. Why do I have to use the keyword this?
Because you're within the class itself.
Exactly. I'm within the class itself. Over here in demo, outside the class, how did I refer to the variable that represented me? Me. How did I refer to the variable that represented Jane? Jane. But once I jump inside the class, do you see any references to me or Jane? You can't. This is a blueprint. This is a class that represents an abstract student. So, and I wouldn't say, Chris is giving you a lecture right now. Chris is going to have to do a bunch of grading later on, right? How would I say, what would I say? I, right? Me, myself, I. Well, we don't want to personify or anthropomorphize classes. So this is an object, and so how would an object refer to itself? Right? This, right, as an object. Right? Of course, the robots would, of course, refer to themselves as me, right? Right? There are languages that use me, capital M-E. I think that's Visual Basic uses that. You can use self in some languages. I think Python uses that. So me, myself, I, but I don't think anybody ever uses I. Instead, they use this. Okay? All right. What are you complaining about still? All right, it's not used. We'll use it later. Okay? Let's do one more thing here, and then we'll go back to C. Let me go ahead and print me out. All right, system.out.println me. All right. And then we'll also print out Jane here. There we go. So predict, what's it going to print? What do you think? It's going to print like Chris Burke, blah, 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 blah. Nope. It's going to print something mysterious. What is that mysterious thing right there?
Memory location.
It's the memory location of that object. It's the fully qualified the fully qualified package name, along with the class name, and then the @ and then the rest of it is just a hexadecimal representation of its memory address. I don't want that. I want it to print out my name, last name, comma, first name. So we can go into the student class and provide the third part of this, or at least a little bit of the third part of encapsulation. Group the functionality that acts on that data inside the class, or with the data inside the class. Right? So to do that, I'm going to create a public string to string method. In other words, it's going to be a public method. It's got to be public because if you want the outside world to use it. It's going to return a string, and it's going to be called toString. And this is because it's actually inherited from the object class. There's already an implementation for it. The implementation, though, is to simply output the memory address of the object. So I want to change or override that default behavior and provide my own default behavior, my own behavior here. What I'm going to do is I'm going to simply return this dot last name concatenated with a space, comma space, and this dot first name. Once I do that and come back over here to demo and run it, now it'll be Burke, comma Chris, and Doe, comma Jane. Again, that was a lot to type. Is there a better way? I do like that formatting, so I'm going to go ahead and save it. Source. Ooh, generate toString. Right? And well, what do you want to print out? I just want to print out the first name and the last name. So first name and last name, and it'll generate it for me. No, I also want to print out the NUID. All right, let's generate that. Now that's going to be the default. When you actually run this, it's not going to look pretty. Right? Students, and then just a comma delimited list of key value pairs. But that's what you get for paying for nothing. Right? You get what you pay for. So, but it gives, at least it gives you a start that you can then go in and manipulate it and get it to look something like this instead. Right? You can't have two string methods. Choose one or the other. Right? And I'll go ahead and choose this one. Yeah.
The one that I created for us, did you use this when printing out that page?
It's bad practice. It should. Let me find out. Is that a configurable? Source, toString. Yes, I want to override it. Skip null values, limit number of items. I don't see. Yeah, that's just the default. You can bring in like outside packages that will pretty things up for you if you really want to. Using string concatenation. Nope, it doesn't look like that it will ever use this. Probably because there are no parameters to get confused with, and so it feels it's not necessary. But it's still best practice to always use the this keyword. Right? It's called open recursion because you need a way to refer to yourself. Right? Who am I? I am me. You're an object. Who am I? I am this. Right? So you're referring always to yourself. Right? Okay. So that gets us in a good position to continue that development. But let's catch up on the C front. Right? Yeah, here, I'll just put these in as observations. We mentioned all this stuff before, but it's similar naming conventions, upper camel casing for the class name, student, capital S. No pluralizations. Lower camel casing for member variable names. You can use public, and then anything can see and modify the data. You can use protected, or lack of the keyword is package protected. Protected means that only subclasses can see it, which goes beyond the scope of this course. The one that you'll want is to keep things private. Keeping them private is a very good thing, and you need a very good reason not to do so. And I capitalized very good reason, VGR, right? So, all right, let's go back to C and discuss what we've been doing within Java in the C version of it. So once you've declared a structure, of course, you can then start manipulating it. Let me go ahead and go back over here and create me again. Right? So student, me. Right, there we go. And if I want to set my first name, .me.first name is equal to Chris. Is that how we set strings, though? Nope. I mean, you could do this, but then it would end up being like a read-only kind of thing, and even then it's kind of icky, right? I would need to string copy, and before I do string copy, what do I need to do? I need to create enough room to hold CHRIS. +1, why? The null terminating string, right? So let's do this properly. I need to set up the memory first. So me.firstname is equal to a call to malloc, casting the return pointer, malloc, size of char, and then in this case it's going to be chris plus 1, so times 6. Okay, that seems kind of tedious. strcpy me first name, oops, me dot first name, Chris. There we go. All right. Man, that does seem tedious, doesn't it? Is there a better way? Because I'm going to do the exact same thing. I'm going to copy pasta for last name. Last name. B-O-U-R-K-E. That's 7. 6 characters plus the null terminating character. Right? Okay. I got my first name, my last name. Me.nuid. That's just a number, so you can just go ahead and go with 351406002, just the assignment operator. My GPA, likewise, 3.5. All right. What else was there? I forget now. My year and my date of birth. All right. Me.year is equal to senior, I don't know. And me.date of birth. Uh-oh. How do I set that? Me.date of birth. What is that? It is a date. What is a date? It is a year, a month, and a day. So I would go about using another dot operator. Year 2021. Me.date of birth. Dot month is equal to, I will tell you that I was born in July. Right? Me dot date of birth dot day, I think it was, and I was born on July 9th. Right? Last year. Right? Not a couple of years ago. Right? No, or not a couple of months ago. Right? Okay. Man, that seemed tedious. Is there a better solution like we had in Java, where we created a constructor? Well, unfortunately, there's no button up above that says source, generate constructor using stuff. But we could go ahead and create a function to do it. Right? So let's come over here and create a function. What should I call this function? I could call it construct, right? Construct student, or create student, or something like that. What do we want? And by the way, I shouldn't define, this is going to be the header file, so it's just the signature. Right? First of all, we'll figure out the name here in a second. What should it return? A structure, right? What kind of a structure? A student structure. This will work, but it's not going to be ideal. What's going to happen is, however many bytes a student takes is going to be it's going to be created on the stack, and then all those bytes are going to be copied to the return value. Just like when I return an integer, there's some local variable integer with 4 bytes. Those 4 bytes get copied and then sent back to the calling function. Here, it'll work, but it's not ideal. What I want to do is I want to create this on the heap, in which case I want to return a pointer to a student. I'm going to dynamically create this thing. Right? We'll look at alternatives here as we go along, probably next time. But what is it going to take? All of those things, right? The first name, char, star, first name, char, star, last name. By the way, am I going to be making changes to your parameter variable? No, I'm going to take whatever's in your first name, and I'm going to make a copy and put it into my first name. So what could I do to advertise the fact that I'm not going to change your stuff? Const. Excellent. Const. There we go. And it's sometimes usual to align things in a list like this. What else is there? Int NUID. Why? Just to avoid long lines. And then what else? year, double GPA, date, date of birth. There we go. Or I could break that down and take a year, a day, and a month, and then I'll create the date of birth for you if you want me to. Right? But we'll go ahead and keep it simple like this. Right? Now, of course, I need a student.c source file to put my actual implementation. And what's that going to look like now? I think I donked. Okay. Now I'm going to take that and I'm going to put that functionality over here into this function here. So let's go ahead and translate all this stuff because I'm no longer talking about just me, my stuff. I am talking about anybody's NUID that you give me, anybody's first name, anybody's last name. So we need to make this more general, first of all. If I go to return a pointer to a student, can I ultimately return me? Like this? Is that a pointer? Nope. So I need to make it into a pointer. And I shouldn't call it me. I should call it what? S? Student, student, or student S, since it's, there's no better name, right? You can go ahead and use an abbreviation here. Right? It's the abstract idea of a student. There we go. All right. So can I just go ahead and start immediately setting stuff? First name, ... Does this exist yet? It's just a pointer. What does it point to? Nothing? Dead beef? Garbage? Null? Right. What do I need to do first? I need to set up memory to hold this student. Right? I need to create this box here. Right now, student is just a pointer. There's a pointer out here that is pointing to this thing, but not this thing, but it's pointing to some random location. I need to create this box dynamically through malloc. Right? So S is equal to student star malloc. How many students do I want? Just one. How many bytes does a student take? I have no idea. Let's go back over here to the H file. A pointer is generally 8 bytes. So 8, that's 16. An integer is 4, so I'm up to 20. This is probably going to be another 8, maybe 4, I don't know. Big question mark there. This is going to be 3 integers, so that's 12 bytes total, and I've already lost count. Right. Is there a way that I can determine how many bytes something takes? How many bytes does an integer take? Size of int. So how many bytes does a student take? Size of student. Compilers are dumb, but they can go to this declaration and say, there's 8 bytes, 4 bytes, and keep it track. And okay, you've got 40 bytes there, whatever it is. Right? All right, and you only want one of them, so technically you could go ahead and get away with this, but I'm going to leave that there as an emphasis that we're only creating one student. And then we're going to ultimately return a pointer to that student. Let me go ahead and get rid of all of this. There we go. Not get rid of it, but just remind myself of everything. So let's take care of that first name. Right. First name. Steal this code. Malloc, size of, it's not always going to be 6 now though, is it? You gave me a first name. It could be Joe, only 3 plus 1 for the null terminating character. It could be Jane, 4 plus 1 for the null terminating character. How do I determine how many bytes you need? str, length of first name. There we go. Is that right? chris plus 1. There we go. And put that into parentheses proper like. Right? And now I can go ahead and copy into me, first name, not Chris, but first name. In fact, I'm going to do this twice. If I'm doing something more than once, twice, thrice, 4 times, 5 times, what should I be doing? Make a function, a deep string copy function. Right? Yeah. Sorry, S. Yes, thank you. It's not going to work anyway, though. GCC C student.c. Error. Well, oh, okay, sorry. I should have included errors, but not the errors that I wanted. Student.h. This will get rid of those errors. There we go. And there's only the error that I wanted. Okay. It's giving me a spoiler here. All right. Well, first of all, I also need what else? String. Fine. Include string. There we go. Get rid of the warnings. All right. There we go. And the standard library. Fine. All right. There. Now I'm only getting the error that I wanted. Error. S is a pointer. Did you mean to use this? And unfortunately, that's a spoiler that they added apparently. S is indeed a pointer, right? So let's think about setting the NUID here. S.NUID is equal to that NUID. Can I do that? I need to dereference it first, right? I need to dereference S to take it from a student star, a student pointer, and change it into a regular old student so that I can use the dot operator, the direct component selection operator, the dot operator. Well, this will also not work because the dot operator has a higher order of precedence than the dereferencing operator. So to solve that, I have to put in parentheses. Dereference it first, bringing that dereference up to a higher precedent, and then using the dot operator, the direct component selection operator. But that is so tedious that they added some syntactic sugar to do it in one line. Instead of doing that, I'll just go S, and then hyphen, and then greater than. But the hyphen and greater than together give you what? An arrow. And so we call that the arrow operator. It is the indirect component selection operator. It's the arrow operator. Right? So if you've got a pointer to a structure, you use the arrow. If you've got a structure, you use the dot. All over here, we have to change all of those dots into arrows. Right? Same thing with the last name. Last name, copy pasta, copy pasta, copy pasta. There we go. That's the risk of copy pasta, right? What did I do? Does it look right? Yeah, this one. That's the risk of copy pasta, that you miss one of them. So be careful. I took care of the NUID, GPA. All right. Yeah, let's just take care of the rest. Really, actually, no. It's kind of boring. Actually, no. Let's take care of the date of birth here. Date of birth. That assumes that it's already. Oh, there's really nothing to take care of. S, date of birth is equal to date of birth. But what is that? What is that design choice here assuming? It's assuming that the outside world has already created this date of birth in order to give it to this initialization function. So, this is called a factory function too. Why is it called a factory function? It manufactures stuff. What does it manufacture? It manufactures student instances, right? Do we want to keep construct or create or what? Construct, I'm fine with that. But it's a factory function that creates things. Instead of you having to do this over and over and over again, you hand it off to a function and it takes care of all that stuff for you. But our design decision here was that we're going to still force the outside world to create a date so that we can set it in here. Okay, fine. An alternative would be to give me all of your year, your day, and your month, and I'll take care of the rest for you. Right? But otherwise, we'll go ahead and keep it like this. S year is equal to year, and S GPA is equal to GPA. There we go. All right. Questions on that so far? Otherwise, how would we end up using it in our demo here? Student S star S is equal to construct student And then 1, 2, 3, 4, Jane, Doe. I should rename it Jane then, right? Jane, Doe, what else was in there? Jane, Doe, year, GPA, date of birth. So, freshman, date of birth, I'm gonna have to do. There we go. And GPA. So she was doing well 4.0. There we go. Right. Questions on that so far? Otherwise, we'll have to continue it there next time. All right. All right. I'll see you on Thursday then.